Hello all, I am Navayuktha. I am here take a topic is multi-terminal HVDC system. In a multi-terminal DC system has more than two converter stations. Some of them are rectifiers and others are inverters. The simple way of building MTDC system for existing two-terminal system. They are introduced as tappings and by parallel operation of converters and bipoles. They are viewed by a multi-terminal system. It is not a trivial. The complexities of control and protection increases considerably, and the use of HVDC breakers is generally required in the MTDC systems. The applications of MTDC systems, there are three applications: bulk power transmission from several remote generating stations to several load centers, asynchronous interconnections between the adjacent power system. A MTDC system interconnecting is more flexible and economic than employing several two terminals and terminal DC links. The reinforcing of an AC network which is heavily loaded. The application 1: bulk power transmission from several remote generating stations to several load centers. Here each generating plant is connected directly to a rectifier station, thereby dispensing with the AC collector system. Similarly, a converter station at each load center eliminates the need of a build additional AC or DC lines for flexible energy exchange. Here, the rectifiers both are connected into inverter. The R1, R2 are rectifiers and I1, I2 are inverters. Applications 2: asynchronous interconnection between the adjacent power systems. When more than two systems are involved, a multi-terminal DC system for interconnected is more flexible, economical than employing several two-terminal DC links. Reinforcing of a AC network which is heavily loaded. Consider an urban power system which is fed by a distant power station. It would be advantageous to arrange to power injection at more than one point and underlying AC network is not overloaded. This is easily achieved by using MTDC system with one rectifier station and several inverter stations. Here the AC system is shown. The rectifiers and inverters, and there are two types of MTDC system: serial MTDC system and parallel MTDC system. The parallel MTDC system, there are both two. They are radial and mesh. Serial MTDC system, which means that is a natural extension of two terminal with system seriously connected to the three terminal. A three terminal MTDC system is shown in the figure. This shows a monopolar arrangement. However, homopolar arrangement with the two connectors is also possible. The system is grounded at only one point which may be convenient chosen. When the insulation is adequate, the grounding point can be shifted based on the changing operating conditions. The grounding capacitors may also be used to improve installation coordination and system performance during transients. The series connected system, the current is said one converter station is common for all stations. The remaining stations operate at constant angle or voltage control. In order to minimize the reactive power requirement, they losses the valve damper circuits. The normal operating values of the firing angle may be adjusted using the tap charge control. At all times, the same of voltage across the rectifier station must be lower than sum of the voltages or inverter station. In case of a drop in the voltage at the current controlling rectifier station, the inverters with a large current reference takes over current control. The switching in or out of bridge is accomplished by deblogging or block and bypass in a manner similar to the two-terminal system. The clearing of fault in the DC system is also similar. The power reversal at the station is done by a two-terminal system by reversing DC voltage and converter control. However, in an MTDC system, the central would require adjusting the current in response to changing loading condition. The local current control of power would imply adjusting voltage and converter station using a angle and tap controls. By using angle and tap controls, we can adjusting voltage, okay, using only one bridge or a 12 pulse unit for voltage control, and operating the remaining bridges or minimum delay angle can be reduce the reactive power requirements. Parallel MTD system. The figure is shown in below. The operating philosophy of a constant voltage AC system is extended to DC system. The current in all the converter station except adjusting according to the power requirement. One of the terminal operates as a voltage, the setting terminal at a constant angle or voltage. A radial system is one which is a disconnection of the segment and transmission would be result in interruption of power from one or more converter stations. In mesh system, the removal of one link would not result in a disruption, provided by a remaining links they are capable to carrying required power with an increased load also. Evidently, a mesh system can be more reliable than a radial system. The figure is shown. The rectifiers and the inverters. The topology and the advantages, disadvantage of a radiation topology, ring topology, simple mesh topology, complex mesh topology. Radiation topology advantages simple, less investment and no DC bus. And ring topology structure and operation is so simple. Simple mesh topology advantages improved safety and reliability. The complex topology, the complex mixed topology. The advantages are highly reliability, flexible power transmission, and reduces the minimum connection distance between the DC nodes. The disadvantages also in this topologies. Radiation topology, there are poor reliability. Ring topology disadvantages are poor reliability, long distance, large transmission loss, simple mesh topology, slightly increased with the length of the line, complex mesh topology, line long and cost is so high.